So we're going to start off by doing experiment 2 on solution, solubility, and colligative properties. So solutions have two components. They have the smaller component, which is called the solute, and then they have the dissolving medium, which is called the solvent. So when two liquids are mixed, they mix either uniformly or non-uniformly. So say we have mixture A and mixture B. If they were to mix uniformly, we would get a resulting mixture of C. If we have mixture A and B that don't mix uniformly, so they are non-uniform, then we get two layers. So this one is said to be miscible, and the non-uniform is said to be immiscible. So an example of this is ethanol with methanol. These two will be immiscible due to their intermolecular forces. They have very similar intermolecular forces, so when they are mixed together, they mix uniformly. However, an example of immiscible would be oil and water. As we know, oil is nonpolar and water is polar. So again, due to intermolecular forces, if they have similar intermolecular forces, they are miscible. If they have different molecular forces, like we see here, then they are immiscible. Here's an example of concentration problem. It's found in your pre-lab. It states that concentrated hydrochloric acid is a 37% weight of HCl aqueous in a solution. The density is given as 1.18 grams per milliliter. The first problem is, what is the mass of 1 liter of this solution? So we're going to start the 1 liter. We're going to multiply it by 1,000 in order to get it to milliliters. And then we're going to multiply by the density. When we multiply by the density, the milliliters cancel out, leaving us with grams of solution. The second problem is, how many grams of HCl are contained in 1 liter of this solution? So now it's asking for grams of the solute. So we are going to be using the weight percent, which is mass of solute over mass of solution times 100%. This, once we multiply it by the mass of solution, which we found previously, we can easily calculate the mass of solute. So we're going to start by using the weight percent of HCl that was given in the problem, which was 37%. We're going to divide it by 100 in order to get it into a fraction mass. Now that we have 0.37, that means we have mass of solute over mass of solution. When we multiply by the mass of solution, it cancels out, leaving us with a mass of solute. Once all of this is calculated, we are left with 436.6 grams of solute of HCl. The following question asks, how many moles of HCl are calculated in 1 liter of the solution? So we already have grams of HCl. We can easily calculate the moles of HCl by dividing by the molar mass. This can be found in a periodic table. You simply add the molar mass of hydrogen with the molar mass of chloride and divide them together. You'll end up with the moles of HCl. So part of your lab, you're going to be asked to form a net ionic equation. And here's just an example of how you do that. So you start with a balanced molecular equation. In this example, I'm going to be using silver nitrate reacted with HCl to form silver chloride and nitric acid. So you start by breaking break all your soluble, strong electrolytes into their ions. So anything that's aqueous is going to break up into its ions. So here I broke it up and went ahead and did the step 3, which says to remove all of the spectator ions. So spectator ions are anything that doesn't go into forming your precipitate. So our precipitate in this instance is the silver chloride. So silver chloride consists of silver and chloride. So we're going to take away our nitrate and our hydrogens. So once we take these away, we're left with silver chloride in our precipitate. And then we write out our equation with whatever is left. And this is what it should end up looking like.